Hello, shall we start?
Sir, we should start now.
Yes, I think so. Now is 8:15. So you see, I have uploaded one textbook. So please look at the book and please download it. I think you have these books. This is Calculus by Anton, the 10th edition. Do you have this text? Please check this. Please check it. Please look at the book. Did you see the book? Hello?
Yes, sir.
Okay. Still, students are coming. You see, students is still coming. Wow. So today I'm going to talk about the parametric equations of lines. Parametric equations of lines. So before going to start this, we can say, for example, we have the line x plus y equals to 1. For example, this is basically a straight line looking at the equation, but now we are basically talking about the 3D geometry. So in case of the 3D, so we have basically the three axes. This is, for example, x-axis. This is, for example, y-axis, and this is, say, z-axis. And the axes are located at the point O, that is simply the origin. Okay, this is our origin O. So, for example, this is, for example, 1, 2, 3. This is 3 units along the x-axis. And then, for example, these are the parallel lines. For example, here 1, 2, 3, 4, 5, 6, for example. And this is 6 axis. Yeah, I mean that we are traveling along the y-axis. And then, for example, we have another line, let's say 1, 2, 3, 4, 5, 6, for example. So this is also the 6 along the z-axis. So you see now, we travel along the x-axis is 3 units. Travel along the y-axis is 6 units. And travel along the z-axis is 6 unit. Okay. So now the point is located here. So this point now takes the coordinates 3, 6, and 6. So we can add, let's say this is a point P, and we can add these 2 points. This is OP. So this is basically the coordinates in the X, Y, and Z. X, Y, and Z. So we can say this is X, Y, and Z plane, or maybe the surface. So that is a point O, and this O, now the coordinates is 0, 0, 0, and here we have the 3, 6, 6. Okay. So now, for example, we are taking another example. Let's say this is X, say this is Y, and let's say this is Z. So this is our X prime, and this is our Z prime, and this is our Y prime. So prime indicates, for example, X prime indicate X is negative, Y prime, Y is negative, and Z prime, Z is negative. So let's say now the point, for example, 1, 2, 3, 4. So this is the 4 units from the origin. And let's say that is the another, let's say 1, 2, 3, 4, 5. This is 5 along the negative Y prime, I mean the negative Y axis. And let's say now we have the another point located 3, 4, 5, 6, for example, here. So this is our 6 units along the Z axis, I mean the Z prime. So what is the coordinate of this point? Let's say this is the point P. So the coordinates is along the X prime we travel 4. That is our minus 4 because we traveled 4 units along the X prime. That is minus 4. And then we traveled 1, 2, 3, 4, and 4, I mean, yes, 5. 1, 2, 3, 4, 5. So 5, that is our minus 5. And Z, that is our minus 6. So the coordinate of P now, minus 4, minus 5, and minus 6. So this is the coordinate for the point P. So now, come to here, we have the X plus Y is 1. So this is basically a straight line. Looking at this equation at a glance, this is basically a straight line. But now we are sketching this in 3D. In 3D. So in case of the 3D, what is this? So please look at here. This is X, Y, and Z. If we say Y is 0, then X is 1. And if we say X is 0, then Y is 1. So I mean, we travel along the x-axis is 1 unit, and travel along the y-axis, for example, also in 1 unit. So this is the point, this is the point. So we can add these 2 points. So this is basically this is straight line, but now we are looking this straight line in 3D. So what is this? Basically you see now here Z is absent. Z is absent. So this is Z axis. So we can draw some parallel lines from this point to the Z, and from this point also parallel to the Z, for example. Okay. So we can draw 2 parallel lines from the 2 points. So always, whenever we draw the plane in 3D, we must have the x, y, and z. But here, for the x plus y equals to 1, we don't have any z. So that means the plane must parallel to the absent, I mean to the z axis, because z is absent here. So we can just draw these 2 lines. So this is basically our plane. Okay, this is basically our plane. So for example, if we would like to take the line like this, say y plus z is 2, then what is this? So you see now this plane, looking at this plane, x
Sir,
is,
can you allow others to join?
okay, just a moment. Okay. So now here you see y plus z is 2, that means x is absent. So the plane parallel to along the x-axis. So now we can draw the yz line, and then we can draw that this yz line is parallel to the x-axis because x is absent here. So now just looking at the plane, this is x, y, and z. So you see if z is 0, then y is 2. For example, this is u2. And if y is 0, then again this is u2. So we can just adding the point, and this line now must parallel to the x-axis. So we can draw some lines from here. So now we can add. So this is basically our plane. Okay. So now come to here. For example, x plus y plus z equals to say 3, for example. So now you see the x, y, and z, the both three coordinates are now present here. So can we write like this? For example, x by 3, y by 3, and z by 3 is our 1. And so we can write this equation in this form. So now if we take y and z 0, y and z 0, so how about x is 3? So this implies the point is now 3, 0, 0. If we take x and z is 0, that is y is our 3, and the point is x0, y3, and z0. If we take x and y 0, then z is 3, and the point is 0, 0, and 3. So we have now the coordinates along the x, y, and z. This is the coordinates along x-axis. This is the coordinates along y-axis, and this is the coordinates along z-axis. Because in x-axis, we have always y and z0. Y-axis is x and z0, and similar to the z. So now, just plot these 3 points in a plane. Then finally, we will have the plane. So now, 3, 0, 0. So this is 1, 2, and 3. So this point, for example, this is A, is 3, 0, 0. 0, 1, 2, 3, and 3, 0. So this point is B, for example, 0, 3, and 0. And we have another point is here, let's say C. And this is our 0, 0, and 3. Okay, so now we get the 3 points. And now adding these 3 points, so this is our required plane, ABC plane. We are locating here. Okay. So now we can just write the parametric equation. So what is this? So please look at the geometry very carefully. Then this will be very easy to understand the picture, what we are going to do. So this is our x, y, and z plane. So just what is the parametric form? So the parametric form, it means, for example, we have a line, say L. So this is the line L, okay? So we are just tracing any line L. And then we take the point here, for example, P within the line, and the coordinate is X, Y, and Z, okay?
Sir, some people wants to join.
But I don't want to allow them right now because it is now the 8:30. Okay? So I don't want to allow them. So this is our Z, 0. So we can just add the line OP. And just we take another point, for example, this point is say P naught, for example. I mean the line L now is passing through the point P naught, and its coordinate, let's say x naught, y naught, and z naught. So we can add the point. Okay. So now what will be the distance of P naught? This is the distance P naught. And now this is the line L. So we take a vector that is parallel to the line L. So just take a vector, let's say V. Okay. So how we can choose the V? That V is parallel to the line L. Okay. So this is another line V, and that is absolutely parallel to the line L, and its coordinate, for example, A, B, and C. Okay. So now we can, let's say OP is our R, and OP naught, let's say R naught. So how about the PP naught? How about the PP naught? So PP naught is our R minus R naught. Am I right? Isn't it?
Yes, sir.
So now you see this line, I mean the PP naught is parallel to V, that is R minus R naught is parallel to V. Okay. And we know if the two lines are parallel to each other, then one equals to the scalar multiple of others. So we can write from here, for example, R minus R naught, that is, let's say, TV. T is some kind of the parameter. Okay, T is any parameter. T we call the parameter. Okay. So now we can see the R minus R naught is TV. Okay. So what is our R from here? So R is R naught plus TV. So this is the equation of the line L. This is the equation of the line L passing through the point P naught and parallel to the vector V. Okay, and parallel to the vector V. Okay, so the equation is R equals to R naught plus TV. So we can write the parametric equation of a line, say L, passing through P naught. The coordinate is x naught, y naught, z naught, and parallel to the vector v, and that is our ABC, is given by R equals to R naught plus TV. Okay, so this is the equation of the line, that is L. So now if we take R equals to x, y, and z, R naught, x naught, y naught, z naught, and v, a, b, c. Then what we can write from here, this is our x, y, z, and x naught, y naught, z naught, plus t, a, b, c. So from here, we can easily write x equals to x naught plus at, y equals to y naught plus bt, z equals to z naught plus ct. Okay, so this is the equation of the parametric line. X equals to x naught plus at, y equals to y naught plus bt, and z equals to z naught plus ct. Okay, so in order to determine parametric equation of a line, what we need the two things. Basically, we need a point, I mean the R naught, and also we need a vector, that is v, and this v must parallel to the line. So now I would like to summarize. To determine parametric equations of a line, we need, number one, a point on the line, that is our R naught or P naught, and two, a vector parallel to the line. If we have these two things, I mean the point on the line and a vector that is parallel to the line, then we can form the parametric equation, that is our R equals to R naught plus TV. So this is the parametric equation. So now we can write this in,
Sir,
yes,
sir, isn't there should be a vector sign in R naught?
no, R naught simply a point. R naught a point, that is our scalar, and T is also the parameter, that is also our scalar. R naught simply a point. Okay, this is not a vector. This is simply a point. Okay, so I I think I'm wrong. These are not also a vector. These are not also a vector. This is, even though this is a point, but this is a vector, okay? So R equals to R naught plus TV,
Sir,
but
some people
T
want
is,
to join.
T is not a vector. T is simply a parameter. It's a scalar quantity. It must be a scalar quantity, this T, okay? T is not a vector. So now I'm talking about the different types of the lines. We have basically the three type of lines. So now,
Sir, can you show the page where you drew the diagram?
yes, at the end of the class, I will upload this so that you can download it from the Google Classroom, okay?
Okay, thank you, sir.
Okay, so can I go back?
Yes, sir.
Okay, thank you. So now the types of lines. For example, we have the two lines, let's say two lines. So the lines, say L1 and L2 are called, number one, parallel. I mean the L1 and the L2, the two lines, the parallel, if they are corresponding vectors, let's say V1. V1 corresponds to L, and let's say V2 that is corresponds to L are parallel. Okay? So the lines L1 and L2 are parallel if they are corresponding vectors. V1 and V2 are parallel. So what does it means? Can we write like this? For example, that is V1 is KV2 or V2 is our KV1. Am I right? Or maybe the cross product must be 0. Am I right?
Sir, could
Yes,
you
sir.
explain why multiplying them by k works here?
Pardon me, please speak more little bit loudly.
Sir, could you please explain why multiplying the vectors by k works here?
Vector sign K.
Yes, sir. Why did we multiply vector 2 by k and vector 1 by k?
Yeah. Yes, because this K, you see, this is just simply the scalar quantity, because if the two lines are parallel, for example, if the two lines, for example, this is L1 and L2, if the two lines are parallel, so it means maybe L1 is equal to the scalar multiple of L2, or maybe L2 is the scalar multiple of L1. So that's why we multiplied here by some scalar, say K.
Okay, sir, got it.
Yeah. So this is the lines parallel. The lines are parallel if they satisfy V1 is KV2 or V2 is KV1, or their product, I mean the cross product is 0. And number two, if they are perpendicular if their corresponding vectors V1 and V2 are orthogonal. So what does it mean? It means the dot product is always 0. If the dot product is 0, then we can say that the lines are perpendicular to each other. And number 2, skew lines mean the lines will never intersect. Skew lines, it means if these are neither parallel nor intersecting. Neither parallel, not intersecting. What does it mean? Maybe the lines like this, for example. This is skew line. You see there is no intersection in between them, or the lines are not parallel. So we can say this situation is the skew. For example here, so this is also the skew. It means the lines are not parallel, not intersecting. So this we call the skew lines. That means what we can say from here is that do not lie in the same plane. Do not lie in the same plane. Okay? So do not lie in same plane. Okay? Do not lie in the same plane. This we call the lines are skew. So basically here we got 3 types of the lines. Number 1, lines are parallel. It means L1 equals to KL2, or maybe L2 equals to KL1. And whenever the lines are perpendicular, it means the corresponding vectors, that say V1 and V2, and their dot product must equal to 0. And the skew, it means the lines will never intersect, or the lines will never parallel to each other. So this situation we call skew lines. Okay.
Sir,
Yeah, pardon me. Can you ask me?
yeah, there is our classmate that cannot join the classroom.
Hello.
Yeah, I say there is our classmate that cannot join the class. What's happening?
Please mute your microphone, and then you can
Yeah,
turn on again,
okay.
because someone is talking and we
Okay,
due
sir,
to
I
this.
say.
Yeah. Yeah, please go ahead.
Sir,
Yes, please.
I say there is our classmate that cannot join the group.
Yes, because you see now is 8:49, so I don't want to allow them.
Sorry?
Now is 8:49, so I don't want to allow them.
So I've been trying to do since I'm finally joining through my roommate's laptop in section 1. We're here together.
Okay, just a moment. Okay. So now I'm going to take some examples from the textbook. So please open the book and go to the chapter. Please go to the chapter 11.5. Chapter 11.5. Can you see the textbook?
Yes, sir.
Okay, so the parametric equation of lines. Still students are coming. So please now look at the problem number 3 and the 4. Find parametric equations of the line through P1 and P2 and also for the line segment joining those points. You see we have the 2 points. Okay, let's say 4B. So just 3 and 4 all are similar. So I would like to take say 4B. The point P1 is -135 and P2 is -132. Then we need to find the parametric equations. So what is this? So now look at here. So we have the point, say P1 is -1, 3, and 5. And P2 is -1, 3, and 2. Okay. So now we need to find the parametric equation for these two lines. And now take what is the parametric equations? So we know x equals to x naught plus at, y equals to y naught plus bt, and z equals to z naught plus ct. Okay. So what is our x naught, what is y naught, and what is z naught? So we have the 2 points now, P1 and P2. So you can choose x naught, y naught, z naught, either P1, or you can choose x naught, y naught, z naught, either P2. So why you can choose this P1 and P2? Why you can choose x naught, y naught, z naught, either P1 or P2? Because you see this is the line, let's say L. So this L line is now passing through the point P1 and passing through the point P2. So you can choose any one for x naught, y naught, and z naught. Let's say this P1 is x naught, y naught, and z naught. So it means -1, 3, and 5. Okay. So we can choose x naught, y naught, and z naught. And the next, we need to choose the vector v, and that's this vector v is our a, v, and c. This is also the vector notation. Okay. So you can write this is in this way within the first bracket, or you can write within this symbol. Both are the same meaning. This is just the vector v. Okay. So what is the vector v now? We have the 2 point. So can we write the vector v? The vector v is the position vector of the point P1 and P2. Can we write this is v? So what is P1 and P2? That is -1 and +1. That is 3 and -3. And that is 2 and -5. So that is our 0, 0, and -3. So this is our vector v, and this is our a, b, c. So our a is 0, and b is 0, and c is our 3. So just put it here. We have x equals to x naught, that is -1, plus 0, that is 0 into t. That is our x equals to -1. And let's say here y naught, that is our 3, plus b, that is also 0 and t, and y is our 3. And here z naught is 5, plus c into t, that is our -3. So that is 5 minus thrice t, and this is our z. Okay. So we have the x is -1, y is 3, and z is our 5 minus thrice t. Okay. So this is our parametric equation. So x is -1, y is 3, and z is 5 minus thrice t. Okay. So you see now from this line, so this is our required parametric equation. Okay, this is our required equation. Required parametric equation. So you see now the point, the parameter t. If you set the t, arbitrarily, then obviously we'll back to the point, we will get the point P1 and P2. So for this, what should we do, or how we can choose arbitrarily to get the point T1 and T2? So what is that? For example, if we choose t is 0, for example, if we choose t is 0, then what is this? X is -1, y is 3, and z is our 5. So we can have the point P1. Am I right? Because P1 is -1, 3, and 5. So if we choose t is 1, then what is this? X -1, y 3, and z is our 2. So it means point -1, 3, and 2. The point is P2. So if we choose the parameter t arbitrarily, then definitely we will have the original point P1 and P2. Okay. So now let's say another 2 point, say P1 is 0, 1, P2 -3 and -4. So we need to get the parametric equation for these 2 points. So now again, we have the vector. We need a vector and we need a point. So we can choose the point. The x0, y0 is, for example, we choose here is 0 and 1. And how about the v is our position vector between the 2 points P1 and P2, that is v equals to P1, P2. and that is minus 3 minus 0, that is minus 3, and minus 4 minus 1, and that is minus 5. So now this is our AB, because we have a 2-point AB. So now x equals to x naught plus at, y equals to y naught plus bt. So x naught, that is our 0, plus a is minus 3 and t, and that is minus 3. This is our x. And we have the y, that is 1 plus minus 5t, that is 1 minus 5t, and this is our y. So we have the parametric equations now. X equals to minus 3t and y equals to 1 minus 5t. So this is our required parametric equation. This is our required equation. So if you wish to go back to P1 or P2, then what should you do for t? For example, if we choose t0, then you see now x is 0 and y is 1. X is 0 and y is 1, and that is simply our point P1. If we choose t is say 1, then what is this? T is 1, then x equals to minus 3 and y equals to 1 minus 5, and that is our minus 4. So x minus 3 and y minus 4, and this implies this corresponds to our point P2. Okay? So now look at the problem number 5. Find the parametric equation for the line whose vector equation is given. So we have the vector equation right now. We need to find the parametric equation. But in the problem number 3 and the 4, you see, we have the 2 points. And from these 2 points, we form the parametric equation. I mean, we find the parametric equation. So now, so look at the problem number 6. Problem number 6a, for example, problem number 6a, we have the vector equation. I mean, the xi plus yj is thrice I minus 4j plus t twice I plus j. So from here, we need to find the parametric equation. So now look at this problem. So we have the xi and yj. T twice I plus j. So what we can write from here? So can we write this is x and y, because xi plus yz, that is x and y. And here can we write 3 and minus 4? And here also t, we can write 2 and 1. Am I right?
Yes, sir.
So from here, what we can write about the x, we can write x equals to 3 plus twice t, and over the y, so y equals to minus 4 plus t. So this is our parametric equation. This is our parametric equation, isn't it? For example, we take another example in the next problem. So look at this problem. So from here we can form the parametric equation. So can we write directly x equals to -1 minus t, y equals to 0 twice t, and z equals to 2 plus t into 0. So this is our twice t, and this is our z equals to 2. So we have the parametric equation right now. We have the x, we have the y, and we have the z. Am I right? Is it clear?
Yes, sir.
Okay. So now we can go to the problem number 7 and 8. Look at the problem number 7 and 8. So we need to find a point P on the line and a vector V that is parallel to the line by inspection. So just take the problem number 8b. Look at the problem number 8b. So this is xi, yz, and zk equals to I plus j minus 2k plus tj. So what we need, we can simply find a point on this line. Just a moment, I'm just need to take a so xi, yj, zk, tj. So this is the vector. So from here we need to find the point. So what we can write from here, you see. So this can we write like this? This is our x, y, and z. And this is 1, 1, and minus 2. And this is t, this is z, that is 0, 1, and 0. Can you write like this? So now tell me what is the point on the line. So this is our R. This is our R naught and T, and this is our V. This is V, this is R naught, and this is our R. So how about the point P naught? P naught, that is here is R naught, and that is 1, 1, and minus 2. So this is the point. Eto is on the line, okay? And the vector V, what is V? V is our Z, okay? V is our Z, is parallel to the line. Am I right? So we have the point P naught, that is R naught, that is 1, 1, minus 2. And this point is located on the line L. And we have the vector V, and this V is now 0, 1, 0. So 0, 1, 0, it means we have the point is Z, okay? So B equals to Z. Am I right?
Yes, sir.
And next, for example, we take another example, xi, yz. So please tell me the point P naught or the point P. What is P? What is our point P? Please tell me what is P. If you wish, you can write this is xy minus 1 and 5, and this is t 2 and 3. So this is basically our point P. P is minus 1 and 5. Okay, is on the line. And what is our V? V is our 2 3, is parallel to the line. Am I right? So now look at the problem number 9 and the 10. Express the given parametric equation of a line using the bracket notation and also using Ij and K notation. So we have the lines X, Y, and Z. Okay. So we need to express this equation using a bracket notation and also using the Ijk notation. So let's say the problem is, let's say x equals to 1 plus t, y equals to minus 7 thrice t, and z equals to 4 minus 5t. So you see now, this is our x naught. Just compare with this. Just compare with this. Just compare with this. So, how about the x naught, y naught, and z naught? What is x naught, y naught, and z naught? X naught is 1, y naught is minus 7, and z naught is our 4. Am I right?
Yes, sir.
And what is ABC? This is our 1, 3, minus 5. You see, this is minus 5. This is 3. And here we have this is 1. Okay. Okay. So we have the vector V is this. So just now write, this is our XYZ, and that is our R. This is our R naught, and this is our V. So we can write R equals to R naught plus TV, and that is, what is our R naught? I 7J 4K, and T, what is our V? I thrice J and 5K. So this is basically our parametric equation in terms of Ij and K vector. Ij and K vector. Okay? Isn't it?
Yes, sir.
Okay. So today I'd like to conclude here. So how about your mid-exam? Did you get any announcement for the mid-exam?
Sir, it will start on January 5th.
January?
5th, sir. 5th of January.
5th of January?
Yes, sir.
Okay. Okay, so we have the time. So on 26, inshallah, I will tell you the syllabus for the mid-exam.
Okay, sir.
So exam will start. So just a moment. I am just making a note. Is January 5th of January
Yes, sir.
until
Sir, we have classes till January 3rd, and midterm exam starts on January 5th and ends on January 16th.
January 16. Okay. Okay, thank you. So now I am uploading the notes. So I uploaded it. Please have a look. Please have a look. Can you upload it? Sorry, I mean can you download it from
Sir,
your
we need
side?
to join the classroom first.
Sir, many of us did not join the Google Classroom. Would you please provide the classroom code?
Okay, I'm just giving you the class code. Okay, so I am sharing it with you in the chat box. Okay, so please look at the chat box. Okay.
Yes, sir, we can see the notes.
Please look at, and I think you can download it right now.
Yes, sir, it works. I downloaded it.
Okay. So